Hi, my name is Sinisha, and in this video I'm going to show you how to get started using the new graph view in the Spine version 4 beta. The graph view has been completely redone to show values across the entire animation. This is very powerful and makes it easier to create great animations. If you have never animated using curves, it can be intimidating at first. Don't worry. I'm going to cover all the basic concepts so you can use the power of the graph for your own animations. Let's open the new graph view and examine what is happening there. You can find it by clicking Views in the upper right in Spine, or by pressing Alt-G. The graph view provides a different perspective of the same data shown in the dope sheet. Like the dope sheet, it uses your viewport selection, has filter, lock, and refresh buttons, and the rows can be clicked to select items. Each row in the graph view has a visibility dot to control which curves are shown. The graph view can be zoomed with a mouse wheel and hotkeys, just like the viewport. To adjust the zoom of the axis separately, hold Alt and drag with the right mouse button. I'll start with basic explanations of the graph view to make sure no one is left behind, and will animate a simple ball. The horizontal axis of the graph view represents time, measured in frames, and the vertical represents value. The unit for the value axis depends on the type of curve. For our animation, we have a translation curve on the x and y axis, so the unit is pixels. Keys in the graph are shown as little squares. As the curve travels across the graph view from left to right, it shows us the value of the x translation as it moves forward in time. So on frame 0, the ball's translate x is 0, and on frame 30, it's 2500. Some timelines keep multiple values. For example, a translate timeline keys both x and y together, even though they each get their own curve. If a key is moved left-right on either curve, it will also move for the other curve. We will add keying x and y separately in the future. Graph keys can be dragged, but currently you cannot select keys in the graph view. Selecting keys will be added soon. For now, you must use the dope sheet to select keys. I will copy the first key and paste it at frame 5, and copy the key at frame 30 and copy it to frame 25. Curves are drawn dimly before and after the actual curves to allow seeing transitions at the animation's beginning and end. This is especially useful when doing cycles. This little arrow button at the bottom of the graph under frame 0 gives more space to see curves before frame 0. The sync button synchronizes the dope sheet with the graph, so the dope sheet will show only the rows for the curves that the graph view is showing. Also, if the dope sheet view is above or below the graph view, the dope sheet zoom will match the graph view zoom so the keys align vertically. The curve between the first two keys and the last two keys is perfectly horizontal, meaning the value is not changing between these keys, only the time is changing. Movement only occurs where there is a change in both value and time, and thus a slope in the curve. In this case, there is a movement between keys on frame 5 and 25. The steeper the slope, the faster or greater the movement. The flatter the slope, the slower or lesser the movement. The direction of the curve's slope tells us the direction of the object's movement. In this case, translate x. Reading from left to right, if the curve is ascending, that means the value is increasing and the ball is moving to the right. If the curve is descending, that means the value is decreasing and thus the ball is traveling to the left. It's not so important to memorize what slope corresponds to which direction. The important thing to note is that a change in the direction of the slope means a change in the object's direction. This will become important when I talk about anticipation and overshoot. Spine has three types of curves: stepped, linear, and Bezier keys. Stepped keys have no interpolation between the keys. Let's leave the Bezier curves active and look at the tangent handles. Every key on a curve has tangent handles that you can lengthen or rotate to affect the shape of the curve between keys. These are necessary to make graceful transitions between your keys without having to manually add a lot of extra in between keys and breakdowns. You can do away with tangent handles entirely by converting your keys to linear, but this will require more keys to get graceful motion and timing. You could place keys every frame, and sometimes that is necessary for fast or precise movement, but is generally not an effective way to work because it does not take advantage of what Spine is best at: smooth in-betweens. When dragging a Bezier handle, hold Alt to prevent the opposite handle from moving. Shift to adjust only the length. Or Ctrl-Shift to adjust the length of both handles. Now that we explained what the graph is showing us, how do we apply that to our animation in a useful way? What do traditional animation timing concepts such as ease in and ease out look like in the graph? Let's talk about timing as it applies to curves. Anytime an object or character moves from one pose to another, you have to decide how to time the action. Does it ease out? Or fast out? Is there anticipation in the opposite direction? Likewise, how does it arrive at a pose? Does it ease in? Or fast in? Is there an overshoot and settle? Which pose do you want to favor? You should ask yourself these questions anytime something moves in your scene. Otherwise, Spine will decide for you. Ease-ins and ease-outs are the most common and are very easy to achieve with a graph. If I were to slightly raise the second key or lower the third key, I will get an ease-out or ease-in. Let's focus on an ease-in for our second pose. But before that, let's click on this button here. The horizontal and vertical axis buttons can prevent accidental changes as keys are dragged. Right now, we don't want to change the timing of our keys, just the value. I select the third key and lower it a little, then tilt its tangent handle so that the curve flows smoothly through it. Now, instead of stopping and holding the pose, it gets almost all the way to the pose and then eases in. This adds some cushion to the end of the action and gives the ball a more natural deceleration. Now I will ease out of the first pose as well. That's it. Simple as that. The amount to move and tilt a key for an ease depends on a lot of things. The distance between the keys, the weight and size of the object, the intensity of the action, and the style of animation. A simple version of anticipation and overshoot can also be achieved easily using the graph. These are very useful for making an object feel alive and resilient. To have the ball overshoot, I simply push the third key slightly beyond the original pose. Then let it return on the fourth key. Likewise, to simulate anticipation, I could drop the second key to have the ball first move in the opposite direction. The next feature I'll show you is the store button. Often you need to do some more experimentation when polishing your curves, and the store button is a great way to try things without worrying about losing your animation. For example, let's say I like the animation I did, but for performance requirements, I want to have as few keys as possible. Press the store button, delete the keys on frame 5 and 25. You can see the stored curve drawn dimly in the back. Now, I will try to match the stored curve using fewer keys. Let's play the animation. As you can see, the result is very similar, but if you don't like it, you can just click the swamp button to store your current curve and return your stored curve. You can go back and forth to decide which you like more. The value and shape buttons control how Bezier handles are adjusted when keys are moved left-right. When neither is selected, the handles don't change as you move keys. When value is selected, the handles change so the curve keeps its minimum and maximum and values, but likely changes shape. When shape is selected, the handles change so the curve keeps its shape. The minimum and the maximum curve values change. Depending on your animation, these buttons can reduce the work needed to fix up curves after you move keys to adjust timing. One little note. See how the curve bends here? When a curve bends sharply or it's very large, it may be possible to see the line segments that make up the curve. This is not a bug. The graph shows exactly how the curve is approximated at runtime. If a curve is not smooth enough, it is easily remedied by adding keys. This was just a quick glimpse at the new graph in Spine. We hope you will enjoy it. Try it out, have fun!